Hello everyone, welcome to Sinx classes. In today's lecture, we are going to discuss problem number 20, 21 and 22 of chapter 3 and exercise 3.3. In earlier videos, we have already discussed from problem number 1 to 19. Please watch my previous videos to have a look at all those problems being solved. So we'll start with the first problem today, and as usual, first we'll try to understand the concept behind every problem and try to solve these problems. So the very first problem is having some expression on the left hand side, and we need to prove it to be equal to 2 sin x. So what we got to look at is again what are the things which are being available to us. Alright, here you have got something in sin x and then something in sin 3x, and in the bottom side you are getting something also in sin square x minus cos square x. This is looking like an expression we already know. So first of all, let's understand the expression. So if you remember, cos 2x is equals to cos square x minus sin square x. This is just the opposite of that, as in, like, if you take minus common, then it will be sin square x minus cos square x. Alright. So can we write this expression as minus of cos 2x? I think we can, right? So this is something which we will do. On whatever we are having here, can we again look at it and then understand what is the expression over here? So it is looking like sin c minus sin d's formula, and we know this is equal to nothing but 2 of cos c plus d by 2 into sin of c minus d by 2. So when you look at this one, if you add x and 3x and divide it by 2, this will also come out to be cos 2x, right? So looking like we got to use this formula to solve the numerator, and denominator has to be solved using this formula. So let's start this problem. So let's start with this. So we'll write sin x minus sin 3x divided by sin square x minus cos square x. So this is nothing but it's gonna be 2 of cos x plus 3x by 2 into sin of what? Sin of x minus 3x by 2. Alright. And the bottom side we will be getting, this is nothing but minus of cos 2x, the denominator. So the top part will become 2 of cos of 2x into, this is gonna be sin of minus of x, and here it will be minus of cos of 2x. So cos of 2x will cancel out, and we also know that sin of minus theta is nothing but minus of sin theta. So we'll use this expression over here. So it will become minus of 2 of sin of x divided by cos of 2x. Sorry, cos of 2x is already gone, right? So nothing is left there, right? And we had a negative sign at the bottom, so that will remain as minus 1, and this will become 2 of sin x, which is nothing but RHS, which we have to prove. Alright, so again, like previous examples, since the left side is a little more complicated, so we start with this and try to reduce this expression to a more manageable form, which is on the right hand side. This is how we solve it. Alright, so let's go on to the next problem. What is my next problem? My next problem is having cos 4x plus cos 3x plus cos 2x divided by sin 4x plus sin 3x plus sin 2x. Again here we have to club some of the expressions together, and we got to make use of the formula cos c plus cos d and sin c plus sin d in some manner. This is how it is looking like. And you also got to observe there is some expression in terms of 3x on the right hand side, 3x, right? So we got to retain 3x somehow and then work with it, right? So can we club cos 4x and cos 2x together and use formula cos c plus cos d and sin 4x and sin 2x together to come to formula sin c plus sin d? Why are we doing that? We are doing that because we can see that cos c plus cos d will be nothing but 2 of cos c plus d by 2. So it 4x plus 2x by into will become 3x. So looks like we will get some cos 3x over there as well. So that's the reason we are clubbing 4x and 2x together. Alright. So let's do that here. So let's talk about LHS. In a way, I'll put cos 4x plus cos 2x together and cos 3x separately, and use sin 4x plus sin 2x together, and then use sin 3x separately. Alright. Now use formula cos c plus cos d. What is cos c plus cos d? It's nothing but 2 of cos c plus d by 2 into cos of c minus d by 2. And what is sin c plus d? It is 2 of sin of c plus d by 2 into cos of c minus d by 2. So let's use this formula. So here it will become 2 of cos of 4x plus 2x by 2 into cos of 4x minus 2x by 2, and then there is another term cos 3x which will be written just like that, and then we will be having same way 2 of sin of 4x plus 2x by 2 into cos of 4x minus 2x by 2, and then I will have another expression over here which is sin 3x. So now this will become 2 of cos of 4x plus 2x will be 6 divided by 2 will be cos 3x, and this will become cos of 4x minus 2x will be 2x by 2 will be cos x, and then here it will be cos of 3x, and at the denominator again it will be 2 of sin of 4x plus 2x by 2 will be 3x. Why? Because this 4x plus 2x is 6 by 2 is 3x. Same way cos of 4x minus 2x by 2 will be x. Why? Because 4x minus 2x will be 2x divided by 2 will be x, and then I'll have a sin 3x over here. What if I take cos of 3x common in the numerator? So I'll be left with 2 of cos of x plus 1, and in the denominator I will take sin of 3x as common, and then I will be left with 2 of cos of x plus 1. My 2 of cos x plus 1 will get cancelled out, and I will be left with cos 3x divided by sin 3x, which is nothing but cot of 3x. Alright. So while we were solving this, we started getting a clue over here itself when this was becoming cos 3x that we can take cos 3x common, and in the bottom sin 3x could be taken out common, and whatever will be left out will be cancelled out. And the first clue was like on the right hand side we had to get cot 3x, so that's the reason we retained cos of 3x in the numerator and then sin of 3x in the denominator, because we wanted to have some expression in terms of 3x itself, right? You could have started with anything. You could have started with cos 4x plus cos 3x also, and eventually you will come to the same expression. But while we choose the expression appropriately, our steps generally becomes less time consuming, and they are generally used to solve the problems quickly. So before solving the problem, just try to observe the expression a little more, and then try to jump into the solution. Alright. So let's move on to the next problem and the last problem for today's lecture. And here we have an expression cot x into cot 2x minus cot 2x into cot 3x and minus cot 3x into cot x, and it is supposedly becoming 1. Alright. So it's a big expression, so something is gonna get cancelled out, and then you will eventually get 1. Alright. So another thing to note over here is there is one thing in positive and rest 2 things are in negative. So something looks like common over here. So what we will do is we'll start with the part which is having negative expression, right? Negative sign. So we'll start here. And say LHS, and we'll have cot x into cot of 2x, and then I'll take minus common, then it will become cot of 2x into cot of 3x plus cot of 3x into cot of x. Alright. Now again we'll have cot of x into cot of 2x, and can I write this as cos of 2x divided by sine of 2x, and I have cot of 3x twice, right? But let's work with it and then write cos of 3x by sine of 3x plus cos of 3x by sine of 3x. I'm just writing cotx as cotx equals to what? I'm just writing cotx is nothing but cos x by sin x. This is the expression I'm using, and why I'm using it is because I look like if I take something as LCM, I will have some expression to work with. All right, so that's the reason I'm doing it, and I'll have cos x upon sin x. All right. Now what I'll do is I'll just keep it as it is, cot x into cot 2x, and here since I have cos 3x in both the expression, I just take cos 3x out, alright, and while taking the LCM, I will have LCM of sine of 2x into sine of 3x into sine of x, right, and here since sine 2x and sine 3x are there, then I will have sine x, and I'll have to multiply it with cos 2x, so cos 2x into sin x, and plus here I have taken out cos 3x common, so I have cos x here, and then here sin x, it is sin 3x actually, sin 3x and sin x are there, then I have to take sin 2x here, so it will be having sin 2x here. So what I did here, again, we took the LCM, sin 2x, sin 3x and sin x. So when I was doing over here, so sin 2x, sin 3x will cancel out, only sin x will be remaining. So cos 2x will be multiplied by sin x. Here sin 3x and sin x will go, sin 2x will remain, so sin 2x will be multiplied by cos x. Alright. Now can you see this expression? This expression is looking a little familiar. It's cos A into sin B plus sin A into cos B, or sin A into cos B plus cos A into sin B, which is a formula of what? It's a formula of sin. It's a formula of what? Sin A plus B. So what is sin A plus B? It will be sin A into cos B plus cos A into sin B. Alright. So here x is A and 2x is B. Alright. So my expression here will be cot x minus cot of 2x minus cos of 3x, and this will become sin of x plus 2x, and here I will have sin 2x into sin 3x into sin x. What is my x plus 2x? This will be 3x, so sin 3x and sin 3x will get cancelled out. So I will be, so x plus 2x is this, right? So sin 3x, sin 3x will get cancelled out. So I will be left with cot x into cot 2x minus cos of 3x divided by sin of 2x into sin of x. Alright. Now look at cos 3x. We just did a reverse here. Can we do something like this? Can we write cos of 3x as cos of x plus 2x? And can I write this as cos A into cos B minus sin A into sin B? Right? So this is the expression, right? Cos A plus B. Yeah, if you don't remember, just write it. This is gonna be cos A into cos B minus sin A into sin B. Right? So we are gonna use this expression over here. So this is gonna be my cot x into cot 2x. Why I am doing it again? Just to have a look. Here I am having something in x and 2x. This is the only odd term out which is in 3x. So I am just trying to reduce this to something manageable like x and 2x, right? So this is what I did. I just wrote cos 3x as cos x plus 2x, and this is reducing to my cos of x into cos of 2x minus sin of x into sin of 2x, right, and divided by sin of 2x into sin of x. Now if I just keep doing it, cotx into cot 2x and divide this separately, this will be cos of x and sin of x. So this will become cos of x into cos of 2x divided by sin of x into sin of 2x. I just rearranged it, and this will become minus minus plus sin of x into sin of 2x divided by sin of x into sin of 2x. So this will cancel out and it will be 1. Now here this part will become cot of x into cot of 2x, right? And this cos upon sin x will become cot x, and this cos 2x upon sin 2x will become cot 2x, alright? And this expression was 1. Now this and this will get cancelled out and I will be left with 1, which is what I had to prove on the RHS, alright? Okay, so just let's look back at this question again and try to understand what we did. So we were given some expression in terms of cot x 2x, cot 2x, cot 3x, cot x 3x into cot x. And since these two terms were in negative and the only one term was in positive, so we just took this common and tried to reduce it to some form wherein the formula were known to us. So we knew that if we reduce it to cos of A into cos of B or sin of A into sin of B kind of a form, then I will have something to work with. When we did that, we got that something is getting cancelled out, and that happened, and we were again left with this expression at this step wherein it was cos of 3x divided by sin 2x sin x. My rest of the terms were in x and 2x, but somehow this cos 3x was still in terms of 3, but rather not in 2 and 1. So I reduced cos 3x again to some form of x and 2x, and thought that something will get cancelled out. This is what was the observation. We were not doing it blindly. We knew that while we do it, this expression is gonna cancel out because eventually we have to have 1, right? So we knew that on the right hand side it was 1, so that's why we proceeded with that. And when we did that, we saw cot x into cot 2x was getting cancelled out and we were left with 1, right? So this is how we did it. It's a little tricky equation, looks like. When you could start with any expression, you could have started with first and second and you still landed on the same result. But in my experience, it looks like that whenever there is some similarity of terms, we should start working with those. Then only we will eventually get to an answer. Alright. So yeah, that's all for today's lecture. If you have any questions, please ask me in the comment section below and I'll be happy to answer. So thank you so much for watching this video and have a great day.